Now let us do moon landing. So let's say this is our rocket. A very bad looking rocket, but let's consider this is our rocket. So how would a moon lander work? There is no atmosphere, right? So what it tries to do is it tries to use rockets. And what is rocket? Rocket is exactly like jumping. Whenever rocket engines are fired, it gives a force in the positive side. And force is also an acceleration. If this is how you need to talk to the students, even if they have not learned things, right? Everything is an acceleration. If you have been watching the sessions which Manish Jain was conducting, he says generally we confuse by adding more terms. Like for example, we say this is an accelerator and we call brake. Brake is also an accelerator. Brake is an accelerator in the reverse direction. The one what we call as an accelerator is an accelerator in the positive direction. Because if you see, when you press a brake, the vehicle just doesn't stop. It slows down, and then it stops. That's a negative acceleration. If when you accelerate again, it just doesn't reach the speed of, let's say, 20 kilometers per hour. It will slowly start from 1, then it will go to 5, then it will go to 10, and then it will go to 20. So it's accelerating. Both are accelerators. So gravity gives a acceleration in the negative side. The rocket engine gives an acceleration in the positive side. But unlike jump, which, like for example, if I press the button and hold it, you don't just jump in the air again while you are in the air. The jumping again will happen only when you have touched the ground. Unlike that, rocket engines actually give a force while you are in the air. So you can do that. So this condition of key -1, right? We need to change it. This is not happening when it is always slowing down. It needs to happen always, even if you are in the air. No matter what you do while you are pressing that value, it will continue to add this positive acceleration from that point in time. This is what rocket engines do. Eventually, this value adds up to so much that it actually breaks the negative acceleration and it starts going up. Right? Have you seen the video of how SpaceX rocket lands? If not, maybe I can later on share it. So they're actually using rocket engines. So when things fall down, at one point they start the engines, it comes down. Now, landing basically means when it is having a negative acceleration here. Take a look at this. There is a negative acceleration there, which basically means, let me say this, that when it is when it is 154 right here, when it is trying to stop it, let me say its value. Let me say the value of minus acceleration. Okay, let me say what is the acceleration that is in looks, right? So say for 2 seconds, and I'll give the change in position here. So take a look what happens. Okay, let's start this. It says -1. Okay, -17, right? -17. What about here? -8.50. What about from here? -5. -16.50. See? Landing basically means when he touches down, the acceleration needs to be close to 0. Close to 0. It cannot be like just 0. It will just float otherwise. So when it is coming down, it has to be close to 0. So something like say -1. -1 is very safe. So -2.50. Right? Yeah. So -9. So maybe something like, yeah. So it should be greater than, we can say, -2. And if the acceleration is greater than -2, we can say it has landed safely. Should be either 0 or greater than -2. And so we can calculate that value. So how do we do that? Is we say we'll fire the rocket, right? And when the rocket is being fired, it will try to continuously add some additional value, right, to this change in position. So that's what we now need to do. So let's quickly do this. How we are going to work it out? This is fine. If the position is this and all of that is just fine. This part is okay. We just need one more additional if here. And that should always work. And we should say here, if sensing, where is that operators, right? I think do it first, maybe here. I can do it here, right? So I'll say if I have rocket engines being fired, where am I? Oh no, I still need to get my change in position. So let's let this change occur. And once this change occurs, and if I have my engines being fired at this point in time, where should I say it should be? While it is greater than -154. Yes, it has to be while it is greater than -154. Here I'll put a check. One more check, right? And I will say, take a look at this, okay? Operators or if condition, right? I need one more if else here. So if else, I need to see whether my key is pressed, and that would be sensing. When space key is pressed, I'm now using a different key here. Or when it is not pressed, this is the logic. But when it is pressed, what should I do? So this will always occur. The negative acceleration would always occur, right? It's just that if, let's say, I'm firing an engine, then I have to continuously add some positive acceleration also to it, right? And it is going to fly only when this positive acceleration is going to be so much that eventually it will just break, it will just cancel this continuous -5, which is occurring. So how should we do that now? So let us say, I will, if this is -0.5, right? I'll say positive acceleration should be 0.6. Remember that to fly, it has to always break, or its positive force should be greater than the negative. So gravity, I'll copy this internal block actually here, but I need additional plus force to it. That is, it will go like this. And this I'll say 0.6, right? So possibly this should work. It's -5 if I press this. So this is not working because it is always on the ground now. So let me first jump. See, it's going up. So I'll actually make this 0.6, maybe 0.7, or maybe 0.8. So run. Yeah, it's going up. See, it's sort of, see, you can now say there is a rocket. So if it lands, and while it is landing, if it's, yeah, see, -2.0, then I can say it is succeeded. So when it is landing, that is in the else part, if my acceleration at that point in time here, I can say, okay, when it has landed, that is when it has actually gone -154, or I can even check that if the velocity is 154, equal to 154, if that happens, then I can sort of stop it. Or it could be this case. Most probably it is going to be this case. And in this possible case, if my acceleration or change in position is greater than -2, say I won, else I'll say I lost. So let's just oops, put the condition here. What do I need to add? Operators, control, if and else. This isn't very friendly. Let me just take this whole block out and split them apart. I'll build something and then I'll move this. So I need if and else. And at that point of time, I'll say if, so I need an operator. If my change in position while it is landing, like while it has landed and when it is stopping completely, is greater than -2, then I would say, obviously, this has to be the case first. Then I'll say not hello, but landed successfully, right? Else I'll say motion, no, not motion, looks, right? Say for 2 seconds. Correct. Then I'll move this whole block here where I was there. So right now it's saying landed successfully. So let's always start from some top point. It's okay, crashed. Okay. Crashed. You have to time it in such a way that it really comes down slowly. Crashed. It's really difficult to always get it above crashed. Let me play a bit of cheat here. Maybe I'll just say -3. Yeah, landed successful. Right. I can actually go and change this part a bit. Right. I have this. I'll remove this part. I'll duplicate this. Right. And I'll say at this point in time, just as an after effect, right? I'll name this one as rockets, and I'll possibly try and throw a flame below. Like this. So I can change the costume. So yeah, going back, there is here, right? If else, if the space is pressed, I'll change the costume looks to say switch costume to rockets, else switch costume to costume. And remember, I just changed something about things, right? So by clean slate, switch costume to costume. And yes, now we can always place him at some given value. So we can always say set the y to maybe 152. So at starting, set y to 152. So it will always start from this point, and let's now try doing it. Ended successfully. Right.